Welcome to Modern Retrogramming with Plasma. This will be episode 9, Function Definitions. In this episode, we're going to cover how to create function definitions in Plasma and the power of a function definition. Our example here is going to be rather simple, but we have an array of numbers and we're going to sort them with a very simple sort function that takes the pointer to the array, the number of elements in the array, and just does a really simple bubble sort. We will compare the two elements side by side and use the multi-value assignment in Plasma to actually swap the two values in the array. Very simple, brain dead, but effective for this example here. It will just keep sorting the array one element at a time until it's fully sorted. We have a simple routine here to print out all the elements in the array as integers. It takes, again, two parameters and it has 0 return values. So here we specify with the #0 that there are 0 return values from this function, making kind of like a procedure in Pascal. Then we will print out the unsorted list, sort it, and print out the sorted list. We'll quickly compile it, speed this up a bit, and we will run it to show that it does what it's supposed to. Our unsorted list and our sorted list. Very simple. Now let's go back and we're going to create two new function definitions. Our first one is going to be one that compares two numbers, A and B, and we'll just simply return one value whether A is greater than B. Since we're returning a value, we don't have to specify the return count because it defaults to 1. We have another function definition, print num, which has 0 return values. And this simply prints the parameter n as an integer and returns. We've changed our sort and print definitions here to call compare num directly on the two elements to get the comparison, obviously. The print routine we'll just call print num to print the array element. So it's not a big change, but bear with me here a second. We'll run this, ensure that indeed is doing the same as example A. And sure enough, it's sorted. Okay, so we're going to go back now, and we're going to use what are known as function pointers. So we're going to take those two definitions of comparing numbers and printing numbers, but we're going to generalize our sort routine to take a function pointer to compare elements. And we are now calling through the function pointer. It looks very similar to the previous example, but this is actually calling through a function pointer to compare those two elements. Same with printing the array. We now have a print element function pointer that's being passed in, and we can use this as a function pointer call. Now notice we actually have to explicitly say that there's 0 return elements because function pointers don't carry that kind of information with them. So we have to explicitly state that in the source code how many return values our function pointer is returning. We call now our print and sort routines with the function pointers, and again it should be completely equivalent to what we did earlier, but now we're getting a more generalized version of our sort and print routines that can take different types of functions to pass in. It doesn't have to be an array of just integers anymore. It can be an array of pointers to structure records that get sorted based on a certain field in the structure record. So this is, although equivalent, it is much more powerful in terms of its general use. But because our comparison is very simple, we're going to use a new feature of Plasma 2.0 called lambda functions, where we can actually pass an inline function that takes parameters and returns a value, or it can actually be multiple values. But in this case, we're going to do the comparison just as we did above, but now as a lambda function. And this allows us to put that code directly in line to our source. Now, what we're going to find is we have an error here. One of the requirements of lambda functions is that they have to be defined inside of a function definition. So they can't be defined in the main init routine of a module. So what we need to do is take this code and put it inside of a definition itself. And that will allow us, and it's just a quirk of how Plasma has to deal with lambda functions. But this is just showing that if you want to use lambda functions, they have to be created inside of a surrounding definition. Usually not too much of an issue, but just showing you here that that's one of the requirements for lambda functions. Now we can rebuild it and run it. Here's where the real power is going to show up. Again, it's functionally equivalent to all the previous examples, but now that we've created this framework, look what we can do with our lambda function. We can take this routine we've created to sort ascending, and we can very easily create a version that will sort descending simply by changing in this lambda function the actual condition that is tested for. That's simple. Now we are going to be able to sort our array multiple ways, or it could be on multiple types of data, all with the same sort routine. And using lambda functions makes it very clean and very simple. So now we get ascending and descending that simply. Well, I hope this has whetted your appetite for the things you can do with Plasma definitions and with lambdas and function pointers. It's all pretty sophisticated, and there's a whole lot more to explore. But appreciate you watching this episode, and this will probably be one of the final programming episodes for Plasma in this series. So thanks for watching. Appreciate it.